Welcome, travelers, to Adventures in Security. In this video, we explore honeypots and honeynets, tools used by defenders to observe threat actor activity before it becomes a full-on attack. You can download the script for this video from the link below. Today we're talking about honeypots, decoy systems designed to be probed, scanned, and attacked by threat actors, on purpose, so we can learn from their behavior. The key idea is simple. If something is not supposed to be used by legitimate users, then any interaction with it is suspicious by definition. That gives us very high signal alerts compared to the noisy world of normal production logs. We'll start with what honeypots are, then move into why you deploy them, how you do it safely, and how multiple honeypots combine into a honeynet. Finally, we'll cover practical tools, how to stand them up, manage them, centralize logs, and turn what you capture into real response actions like blocking, detection rules, and threat intel. Think of this as a tour. Concept first, then architecture, then the how-to playbook. A honeypot is a deliberately instrumented target, maybe a fake SSH server, a decoy web app, or a too-interesting file share. The moment someone touches it, that's meaningful, because normal users shouldn't. That's why honeypots are famous for high-confidence detection. You're not trying to detect all bad behavior on your real systems. You're creating a separate place where any behavior is suspicious. Another key point, honeypots aren't just alarms, they're evidence collectors. You can capture the attacker's IPs, commands, malware samples, credential guesses, and patterns of behavior. And here's the misconception to avoid: a honeypot doesn't protect production by itself. It's not a firewall, it's a sensor and a lab bench, one that helps you detect earlier, understand faster, and respond smarter. So why bother? First, early warning. Attackers often scan and probe for days before they succeed. Honeypots catch that pre-attack phase because they're easy to find or intentionally exposed. Second, intelligence. When someone tries a specific exploit, drops a payload, or runs certain commands, you learn what's trending against your industry and which controls you should tune. Third, honeypots are great for training. Analysts can practice triage and incident response using realistic attack data without risking production. Fourth, you can use honeypots to validate your security pipeline. Are alerts reaching the SIEM? Are playbooks triggering? Are dashboards useful? Finally, honeypots help you measure attacker behavior. What ports they target, what credentials they try, and which breadcrumbs they follow. In short, honeypots turn random internet noise into structured, actionable signals. We usually categorize honeypots by interaction level. Low-interaction honeypots emulate a service, like an SSH banner or a fake web login. They're safer and easier to maintain, and they still catch lots of opportunistic attackers and bots. High-interaction honeypots are real systems, actual OS and applications. They provide richer intelligence because the attacker can do more, but that also increases risk. You must isolate and monitor them carefully. Then there are specialized honeypots, industrial control system simulators, IoT device emulators, decoy databases, or Active Directory traps. And don't forget honey tokens, like a fake API key in a config file, or a decoy document with a beacon. If that token is used, you get an immediate alert, often with context like where it was accessed. The right choice depends on your goal: detection signal, research depth, or training realism. Before you deploy anything, decide what success looks like. If your goal is quick detection, a few low-interaction services on common ports, SSH, RDP, HTTP, might be perfect. If your goal is research, you may want high-interaction systems with file integrity monitoring and full packet capture. Placement matters. External honeypots catch internet background noise and opportunistic attacks. Internal honeypots catch lateral movement, credential misuse, and insider threats. Believability matters too. A payroll server 01 in an internal subnet will attract different attention than a random IP with no context. Finally, be explicit about evidence. Do you want login attempts only, full command transcripts, malware binaries, or network sessions? Clear objectives prevent the two big failures: collecting too little data to be useful, or building something too risky and complex to operate safely. Let's talk safety, because a poorly deployed honeypot can become a stepping stone into your network. Rule 1. Isolation. Put honeypots in their own segment with strict firewall rules, especially between the honeypot network and production. Rule 2. Outbound control. Attackers who compromise a honeypot might try to scan or attack others from it. Limit egress, rate limit, and log everything. Rule 3. Instrument heavily. You want service logs, system logs, and ideally network telemetry, like Suricata alerts or full packet capture, plus reliable time synchronization, so timelines make sense. Rule 4. Never store real secrets on a honeypot. Use fake credentials and decoy data only. And make it disposable. Snapshots, immutable images, or containers so you can reset fast after compromise. The mindset is assume breach, design for containment, and maximize visibility. A honeynet is basically a network of honeypots designed to work together. Instead of one decoy, you create an environment that looks like a small enterprise. A web server, an SSH box, maybe a decoy database, and a fake internal service. The magic is coordination. Typically, you route honeynet traffic through a controlled gateway, sometimes called a honeywall, where you can enforce containment rules and capture traffic. A honeynet helps you see attacker workflows. They might compromise an exposed service, then try lateral movement, then attempt credential reuse, then exfiltrate data. By having multiple decoys and shared monitoring, you can correlate events across the environment and build richer stories. Same actor hit SSH, then pivoted to SMB, then tried dumping credentials. Honeynets turn isolated alerts into narratives, and narratives are what drive strong detections and response. Here are some well-known honeypot tools you'll see in practice. Cowrie is a popular SSH/Telnet honeypot that captures brute force attempts and command sessions. Excellent for learning what attackers type after they get in. Dionea is commonly used for malware capture, emulating vulnerable services to collect payloads. OpenCanary is a flexible option for deploying multiple canary services, like fake SMB, HTTP, FTP, or RDP-style lures, and sending alerts to your logging system. For industrial or OT simulations, Honeypot is widely used to mimic ICS protocols and devices. Honeyed is an older but conceptually useful tool for emulating networks and services. 2 important points. First, tool choice should match your objective. Second, maintenance matters. Some projects are legacy, so always test in your environment and keep dependencies controlled. The goal is reliable signal, not a museum of tools. Operating honeypots at scale is an engineering problem. A popular turnkey approach is Teapot, which bundles multiple honeypots and a monitoring stack into a deployable platform. Great for labs, research, and even some production-like deployments if you harden it appropriately. If you're building your own, automation is your friend. Docker makes packaging easy, Ansible can standardize configuration, and Terraform can reproduce infrastructure consistently. Think in lifecycle terms. Build images, deploy, rotate periodically, and reset after compromise. Honeypots are meant to get dirty, so you need a clean way to return to baseline. Also, treat configs as code, version them, review changes, and monitor health. A honeynet that silently breaks is worse than none at all, because it creates false confidence. The operational goal is stable telemetry with predictable maintenance. A honeypot without centralized logging is just a noisy box. You want all events flowing into a place where analysts can search, correlate, and alert. Practically, that means shipping logs using syslog or agents like Filebeat into a SIEM. Or log platforms such as Elastic, Splunk, or Graylog. Pair host-level logs with network telemetry. Zeek gives you rich network metadata. Suricata provides IDS-style alerts, and packet capture helps when you need deep forensic detail. And then comes the step that turns data into intelligence: normalization and enrichment. Add GeoIP, ASN, known bad reputation feeds, and consistent fields like source IP, destination port username, and session ID. Once your logs are structured, you can build dashboards like top attack services, new payload hashes, or commands seen this week. And you can write high-confidence alerts because honeypot traffic is inherently suspicious. Now the payoff: response. Step 1 is triage, confirm the event, deduplicate repetitive bot traffic, and identify what's actually new or interesting. Step 2 is converting findings into reusable defenses, such as indicators of compromise like IPs, domains, file hashes, and behavior-based detections like SSH brute force followed by wget/curl dropper. This is where formats like Sigma rules or Yara signatures can help your detection engineering. Step 3 is blocking and containment, but with discipline. Honeypots attract lots of background noise. Don't break production access over a random scanner unless it's clearly malicious and relevant. Finally, use workflow tools. The Hive is commonly used for case management and response coordination, and MISP is widely used for sharing and organizing threat intel. The teaching point: honeypots are not just alarms, they're inputs to a feedback loop that makes your overall defense smarter over time. Let's wrap up with best practices. Safety comes first. Strong isolation, strict outbound controls, and continuous monitoring. Remember, honeypots are designed to be attacked, so assume compromise and prevent pivoting. Second, legal and policy considerations. Deploy only with proper authorization, follow your organization's privacy and logging rules, and set retention policies, especially if you capture packet data. Third, usefulness. Don't deploy honeypots because they're cool. Deploy them to answer questions. Are we being scanned for RDP? What brute force patterns are trending? Are attackers already inside moving laterally? Finally, start small. 1 or 2 well-instrumented decoys feeding a central dashboard can deliver value quickly. Then iterate. Add services, add internal lures, build better detections, and refine response playbooks. If you do it right, honeypots and honeynets become a low-noise, high-learning sensor network that improves your security posture week after week. That's it for this video. If you learned anything, please remember to give us a thumbs up and subscribe. And until next time, be careful what you click.